All right, so we had talked about that we're going to do this synthetic division of this, doing it twice, okay? So I'm going to write this as x minus 2, x plus 2, okay? And then we're going to try to do synthetic division twice, and we're going to figure out what that means. Okay, so first I'm going to divide it by that. So I'm going to do the 2, and then 3x cubed minus 2x squared, no x's, minus 150, okay? Then I'm going to do the synthetic division, so bring it down, multiply and put it there, all right? Bring it down, multiply and put it there, bring it down, multiply and put it there, right? And then now we're going to subtract, so that's 40, 39, 38, 37, 36, 35, 34. So negative 134. All right, now let's talk about what this means. This means that it is, what? This one, 3x squared plus 4x plus 8, that's the whole number, plus negative 134 over x minus 2. Now I need to divide that by x plus 2. So I'm going to divide all of that by x plus 2. And that is the same, so this is equal to this, because it's this dividing by both parts of these. I already did this one, and now I'm doing this one. So now let's talk out what that means. Well, that is this plus this one how come I can just put that as the denominator there? Because that's like over 1. So flip and multiply would put it in the denominator here and in the denominator here. Okay? So I split it up into the two parts. This part and this part. Okay? So there I have it. So now I got to do this division. So now I'm going to put a negative 2. And then I'm going to do this one. So 3, 4, 8, and then 3, negative 6, negative 2, 4, 12. So now this, let's see, so keep it, so what's important here is when you're doing mathematical analysis, then like keep everything. Don't lose things and then put them back in later. I see that a lot where you like forget it about a denominator and then put it back in later. That's a really bad idea because when you're doing it, a mathematical analysis, you might lose track of what you were doing, okay? So I did this one and I put this there. Okay, that equals this divided by the x plus 2, so I'm keeping everything. And then just that's the same as dividing it by this, and then this one. So now this is the same. This one is this, so that would be, that's the same as 3x minus 2 plus 12 over x minus 2, okay? This, you don't write over x plus 2, over x plus 2. You don't write, like you're not going to put this over x plus 2, okay? We literally have done each part. We did this, and it became this, okay? So all of this became this. Then plus negative 134 over x minus 2, x plus 2. All right, and then that's an answer. That's valid. That's a valid answer. But let's put these as one single remainder of the original. So I just need a common denominator between these two. So I'm going to multiply this by x minus 2. So you get a common denominator. And then I'm going to switch the order of these two, just so it matches this one. Okay, so then that's 12x minus 24 minus 134 because they have the same denominator. So then that's 130, 40, 58. So then altogether, that's 3x minus 2 plus 12x minus 158 over x squared minus 4. Good. Now that's the synthetic division way of doing it twice. Now, up here in the margin, I'm going to do the long division way because it's actually shorter than doing the synthetic division. So shortcuts are not always shortcuts is the moral of that story. But also I just wanted to work with some fractions there, okay? So up in the numerator, way up here in the margins, we're going to write x squared minus 4. And leave a little bit of space because you got to be able to do long division. Sorry about my coffee stain. 3x cubed minus 2x squared plus 0x minus 150. So now, the other nice part about long division is you write even your x's. Okay, now, how many times does x, now you just do first into first, always. So how many times is 3 divided by 1? It goes 3 times, and then x cubed divided by x squared. So a lot of times I tell students to just kind of write it on the side. 3x cubed over 1x squared. And you get 3x. So put 3x, and then you multiply here and here. So that's going to be 3x cubed minus 12x. Now you do subtraction, because that's how you do long division, you subtract. So then those cancel, and then you get negative 2x squared, and then minus negative, so plus 12x minus 150. Now how many times does this go into this? So again, it's first into first. So negative 2x squared over 1x squared. And that gives you negative, just kidding, negative 2. Okay, so now minus 2. Now you multiply there again. So that's negative 2x squared plus 8. And then you subtract. So those cancel, and then you get 12x minus 158. And that's your answer. So you get 3x minus 2 plus 12x minus 158 over x squared minus 4. See? So long division was actually shorter than short division or synthetic division. Okay? So I know that a lot of times students don't like, well, now I have this here and this was the easier way to do it. I don't care about the easier way to do it. That is not the point at all. The point of this is that you investigate and you figure out what works and you figure out how it works, okay? Yes, the long division was actually shorter, and you are welcome to cross this out and just write the long division or do this again on the back or erase it if you want. That's up to you. It's your notes. What I care about is that you're trying and that you show your work and you are analytical and logical, because the sum of it is that on the exams, on the tests, most questions are not going to involve can you just do this thing, okay? Most of them are going to involve, did you investigate, did you try, did you figure out something, okay? All right, this one, divide. So this says divided, and this says rewrite the numerator using division algorithm. So we did do the divide part. Both of these are the divide part, right? So this is the divide. Okay. Rewrite means to rewrite. So if you think about 17, let me grab my other color. 17 divided by 2 is 8.5. Okay. But also 17 is 8 times 2 plus 1. 8 times 2 plus 1. See, like making a mixed number back into the fraction. You do 8 times 2 plus 1 and then put it over 2. So if you just wanted to write the numerator, you would just do 8 times 2 plus 1. Okay, that's called, this is the division. This is the rewrite. This one's divide. Okay. So if I wanted to rewrite this, it would be this times this plus this. So the numerator equals 3x minus 2 times, so this would be rewrite. Okay. 3x minus 2 times x squared minus 4 plus 12x minus 158. Notice this is not factored because there is a remainder, so it's not multiplied. If it was just this, it would be factored because the remainder would be 0, which is the whole point of factoring, right? Remainder is 0. But it's not factored because we got this plus. But that's not what the question asks. It asks to rewrite, and there's the rewritten form. Okay? This one just says to divide, so go ahead and do that now. Pause the video, try it, then push play and see if you get it. Okay? So x cubed, x squared, x constant, so then that's 5x squared. Now it just says divide, so that's just like 8.5. So 5x squared minus 16x plus 4 plus negative 10 over x plus 2. What does a 0 mean graphically? Take a minute, see if you can think of it. Okay, well, graphically, if it's real, it's an x-intercept. Nothing if imaginary. Okay. How do we solve f of x equal to 0? Well, mostly you factor. Okay. Down to linear and quadratics. And then this one would also be the quadratic formula. How do we know if one number is a factor of another? Well, one number is a factor of another if it goes in evenly, or in other words, if the remainder is 0. All right, decide whether the given number is a root. Okay, so is a root is the same word as a 0, or in other words, the remainder is 0. Okay? Or it also means f of the number equals 0. Oh, f of, well, I call it k here, so let's call it k here. So I think for 1, I'm just going to plug it in. Okay, so f of 1 is 1 minus 4 plus 9 minus 6, which is what? Negative 3 plus 3, which is 0. All right, so it is a 0. All right, this one, I do not want to FOIL out 1 plus 2i. So if I plug it in, that would be 1 plus 2i to the 4th right there. And that way you would have to like multiply that out 4 times, foiling. Okay, so I do not want to do that. So instead, I'm going to do synthetic division, and this is going to be a little bit of a doozy. But it's still better than FOILing out to the 4th power. All right, leave lots of space between, like, each coefficient, okay? So I'm going to put a 1 x to the 4th minus 2, 4, 2, negative 5. Now let's make sure they're all there. 4, 3, 2, 1, constant, yeah. All right, so add, multiply. 1 times anything is the anything, so that's 1 plus 2i. Okay, add, multiply. So you're going to have to FOIL. So I would write it over here, 1 plus 2i times negative 1 plus 2i. So that's negative 1 plus 2i minus 2i plus 4i squared. I squared is negative 1, so that's negative 1 minus 4. Okay, if you didn't know that, you should make a note. You're going to want to memorize that. So that's what I just did here. That's negative 1, so that's negative 4. So we get negative 5. So I'll put that there. So that's negative 1. So then that's negative 1 minus 2i. So then that's 1 minus 2i. Now these are conjugates. One minus 2i plus 2i, so those cancel. Minus 4i squared is 1 plus 4, which is 5. And it's 0. So yes. Now, if you know one of them, if you know 1 plus 2i is 0, you also know 1 minus 2i is 0. So if I were factoring this, okay, then I would also know 1 minus 2i is a 0, okay, because they come in conjugate pairs. Okay? So they come in conjugate pairs. So if I were factoring this, I would totally do 1 minus 2i next and do that like right here. And then a little factor right here. And you know you'll get a remainder of 0 again. Okay? So I would definitely do that here. Now that would be all the way down, so that's a 4th. So this is a 3rd. And that would break it down to a squared, which then you can do the quadratic formula on. Okay? So, but it didn't ask you to do that. So that's why I wrote it in my other color. Okay. It just asked, was it a 0? Okay. Now this one says determine if it's a factor. Well, it doesn't say to actually factor it. It just says to determine if x minus 1 is a factor. So that would be x equals 1 is a 0. That's the question. Okay? Just imagine that equal to 0 and solve it for x. That's what we're doing. Okay? Because if it were a factor, you would use the 0 product property to set the factor equal to 0. Okay? So see? So that's what's happening. Okay. All right. So I don't know what the other stuff is, but if it's a factor, see how it would work? You would set this equal to 0 or this equal to 0. And so you would get x equals 1. So that's kind of like the backwards idea of it. Okay. If you have a factor, you have the 0. If you have the 0, you have the factor. All right. So I'm actually just going to plug in 1 because plugging in 1 or negative 1, I'd rather just do that than synthetic division. It's faster. Okay. If it's other numbers than 1 or negative 1, I would do synthetic division, I think. It depends, again, but I think synthetic division is easier if it's bigger numbers, but with 1, that's easier. So I'm going to do f of 1 is 2 plus 3 minus 5 plus 7. So we get 5 minus 5 plus 7, which is 7. So no. Okay, because it's not equal to 0. I'm going to move that down. So 0 is a remainder. It's also the y value, which makes sense because it's the x-intercept, and at an x-intercept, the y is 0. Okay? So they come together, like the remainders being 0 and the function being 0 are the same thing. All right, so for this one, 3 minus 2 plus 1 minus 8 plus 5 plus 1. Okay, so 3 minus 2 is 1 plus 1 minus 8 plus 5 plus 1. So that's 1, 2, 3. So 3 minus 8 plus 5, which is negative 5 plus 5, which is 0. So yes. Okay. All right, so now we are going to list all possible rational zeros. All right, so to list all possible rational zeros, I call them a lot of times good guesses, is really what I like to call them. And I don't think most other people call them that, so if you see it anywhere else, it's going to be called possible rational zeros. But really, it's your good guesses for synthetic division, okay? And it's all your plus or minus. It's the factors of the constant over factors of the lead coefficient. Okay, so for these, it would be plus or minus 1 and 2 over 1, 2, 3, not 4, not 5, 6. Then you got to write it out. So that's plus or minus, and then all of these. So 1 over 1, 1 over 2, 1 over 3, 1 over 6. 2 over 1, 2 over 2 I already have, 2 over 3, and then 2 over 6 is 1/3, which I already have, so that's everybody. Okay? All right, and then it says find all rational zeros and factor. So what these are your good guesses for synthetic division. Now that's 1, 2, 3, 4, 5, 6. That's 12 guesses, but that's still better than infinite guesses. Okay, which is what you had before you had these, was you had no idea what would work. Okay, now I just like to try my whole numbers first. So that's what I do. So I'm going to plug in 1, which that's how we did synthetic division before. I didn't even tell you about good guesses before. You just literally started plugging in numbers until something worked. And then once you found something that worked, you could go from there. All right, so f of 1, I get 6 plus 7 minus 12 minus 3 plus 2. So that's, what is that, 12, 13. Minus 12 is 1 minus 3 plus 2. So then that's negative 1. Yay, so I get 0. All right, so now I'm going to use that to factor. So I'm going to plug in 1, okay? And then 6, so that's 4, 3, 2, 1, nothing. Which we knew that was going to happen. Now, just because 1 worked once doesn't mean it can't work again. So in other words, you got to try it again. You won't know by plugging it in. You got to try it here, okay? Okay, and that definitely doesn't work. I feel like I'm going to need a negative number, right? Oh, and I know I need to keep going because this is a fourth. So this is a cube. That's not enough. I stop when I get to a square, okay? So I know because this is a 4, I'm going to have to do synthetic division times 2 to get to a quadratic. Okay? All right, so -1. Nope, didn't work. All right. Now you are welcome to not erase and cross out, and I highly recommend that a lot of times on your work for me anyway, because maybe you just messed up something and I see that you tried everything, okay? And I can't see that you tried everything if you erase, okay? All right. Now I'm gonna try 2. Yeah, and I'm gonna stop there. That's just gonna get too big. So let's try -2. Yay. All right, now that's a quadratic. So I know that f of x equals x minus 1, x plus 2. See, don't forget, change the sign. And then 6x squared plus x minus 1. Okay, now I need to factor that. Multiplies to give me -6. Adds to give me 1. Would be 3 and -2? Yes, it would be. So this is going to factor 6x squared plus 3x minus 2x minus 1. So then that's 3x. And then don't forget these guys. Good? Sorry, I feel like it's just giving you maybe a little bit more room. I write kind of, like, I guess I just have an idea of what the spacing is going to be. So when you're taking notes along with me, you should try to keep the same spacing that I do. But anyway, and it says, so list all rational zeros and factor. So we factored it. That's generally the way it's going to work. You're going to factor it and then list the zeros. You can't really do the other way, but they usually list it that way. So now I need to find list the zeros. So not the possible ones, the actual zeros. Okay, so my zeros would be 1, -2, 1/3, and -1/2. I like to list them in numerical order, but it doesn't really matter. So maybe for this one, no. 1, -2, 1/3, and -1/2. Okay? All right. And then I think that's it. And I am going to assign to you some Khan Academy to do after that.